Thank you for watching my video. My name is Mr. Charles Weniken. In this video tutorial, we are going to discuss about autocoupler in alternating current. Autocoupler in alternating current, there are two types, which is SCR and Trex autocoupler. Two other common autocoupler outputs are SCR and Trex. Both types feature high current transfer ratios and are typically used to control higher voltage AC circuits. Image difference between SCR and Trex. Now in this case, we have optocoupler Trex IC and optocoupler SCR IC. They are all 6 pins or 6 leg. Now I want to use this to differentiate difference between the Trex and the SCR. In this case, you can see the symbol. This is a symbol of Trex, while this one is a symbol of SCR. They are all in the same 6 leg. They are both in 6 leg. Here we have 1, we have 2, we have 3, we have 4, we have 5, we have 6 pin. The same thing applicable to SCR IC. In this area also is the same thing. I only double the image here. Now in this case, we also have the same thing here. This one is for SCR, while this one is for Trex. That is just the two. They are all, the similar difference is the symbol being the detector or the light sensors. Here is called light sensors. Here is also called light sensors. We are going to discuss more about it in few coming in the next few coming the tutorial. Here now we have the diode. The diode here is number 1 connected to number 2. The same thing applicable to this place. Here we have this dot signifies 1, it signifies 2. We will also discuss more about it. Now in this case, let's talk about SCR autocoupler. SCR stands for silicon control rectifier, also referred as thyristor. You can also call it thyristor or SCR autocoupler. In this case, opto-isolator SCR and SCR devices use a silicon control rectifier as their detector. These optocoupler are typically used as step-up devices and feature slow to medium switching speed. Now this is the image of SCR. This is the image, SCR autocoupler image. Is apparently that here we have anode, we have cathode. That is in terms of diode. Here 1 and 2 is anode, cathode. Anode and cathode. Number 1 is anode, while number 2 is cathode. That is in terms of the emitter, the one that absorbs the current or the voltage from the source. Now the detector or the light sensors, which we have SCR, it has gate, anode and cathode. All this one, they are all the same thing, but this IL signifies the model number. IL 400 signifies the model number of SCR autocoupler. The only difference here is in this particular place, they did not indicate if it is gate or anode or cathode. They only indicate 6, 5, 4, 1, and 2. Here there is no 3 here, because since there is no 3 here, it means 3, it has no connection. It has no connection. Now, in this case, this diode, which collects the voltage from the source, it will finish after collecting the voltage or current from the source. It will, once it has finished doing its own job, it will transfer it. This particular arrow signifies to transfer the current to this light sensor or detector. In this area, this has something that will dictate that diode has finished its own job, and it will dictate that light is coming or current is coming. So after the detection, this will now collect the voltage and convert it to electrical signal and give it to the output. That is the job of all this particular area that you are seeing here. This 6, 5, and 4, the same thing that I explained. If you have watched the previous video that I discussed on other videos, here this gate, it has its own function. This anode has its own function, while this cathode also has its own function and connection as well. Now, just as I said, here we start from number 1, here is number 2, here is no connection. This N/C, it signifies no connections. It signifies no connection. While here is number 4 being cathode, here is number 5 being anode, number 6 is gate. What I'm trying to explain here is gate is the one that controls the 5 and 4, being the pin 6 control the 5 and 4, which means if this number 1 and 2 might have finished their own work, this arrow signifies that they are sending the current straight to these light sensors or light detector. After finishing its own job, it will convert it to electrical signal. And this particular work of this gate here is for it to stabilize if there is an excessive or if there is a noise coming out from the light sensors. This gate will stabilize it. It will stabilize the electrical noise or whatsoever that will trigger or make this particular thing to be burned or spoiled. That is the work of this particular gate. It will neutralize or stabilize if there is an excessive voltage. It could be noise, it could be whatsoever thing. That is the work of this particular gate, being pin 6. The same thing applicable to this place. Now, in this area as well, in times of the light sensors or light detectors, it has the same. It has anode, it has cathode in SCRO, anode in SCRO, while the gate, just as I explained before. So that is the work of this gate here, is to stabilize or neutralize if there is noise or excessive voltage that is coming out from this diode or from this place. That is the function, is to neutralize it or stabilize it, just to make sure that there is no any issue or error in times of the output. After once this might have finished its own work, it will convert it to electrical signal. Now, silicon control rectifier optocoupler series. It has MOC 3071, IL 400, MOC 3072, and so on and so forth. It also has 4N39, 4N40, and NTE 3091 are a few examples of silicon control rectifier example of auto-coupler, and mostly they are used in AC. Remember, this particular area now is used in AC. What I am discussing right now, these auto-couplers, they are all used in AC circuits. Now let's go straight to the Trex. The Trex optocoupler. Opto-isolator Trex devices feature triode for alternating current. What I mean by triode, this thread that you are seeing here, this AC signifies alternating current. That is why you are seeing this AC, A and C. It signifies alternating current. Why this particular TRI, that is what is here, triode for alternating current. They remove this ODE and replace it with this alternating current output. Threads are similar in construction to SCR, but while SCR only allowed current flow in one direction, these threads allowed for flow in both directions. Threads autocoupler typically feature very high control transfer ratios, which means the difference between the SCR and the threads is, in times of this, threads SCR only allow current to pass through in one direction, while in times of this threads, it allow the current to flow both directions. It means left and right, front and back. It allows current to flow in both directions, and these threads also feature high transfer ratio, high current transfer ratio. Now look at the image of it. Trace image, trace autocoupler image. It has number 1, it has number 2, it has number 3, number 4, number 5, and number 6. This is the internal structure of the trace. The same thing applicable. Now you can see that it also has a model number IL420, all depending on the manufacturer. It could be any number. So all depend on the manufacturer. Now in this case, the trace here, it has, in terms of diode, it has anode and cathode. Number 3, no connection. While in this place here, in terms of number 6 and number 4, number 6 and number 4 are the main terminal. They are called main terminal. While the number 5, it also signifies no connection. It means there will be no connection between number 5 and number 3. The same thing applicable to this place. Now here we have anode number 1, cathode number 2, no connection number 3. You come for that particular triode and the trace symbol. It has anode slash cathode number 4, anode slash cathode number 6. Here in terms of number 5, it signifies no connection, which means when you are using it, you should also remember that in terms of trace, the number 5 pin and 3, it has no connection. The trace autocoupler series. These are the few examples that I was able to find out. It has IL420, 4N35. It also have another series it has many series, all depending on the manufacturer. It has MOC 3010 to 3023. It also has from 50, 30 MOC 3050 to 3052. The same thing applicable here, MOC 3041 to 3043, MOC 3061 to 3063. That one is for 6 pins or 6 leg. In terms of 4 legs here, it has the same thing here. It has number 1 and number 2, number 3 and number 4. You see this S2 and S1, it means first connection. This one means the leg that we connect to the source, that is here, means the leg that we connect to the source, while this one will be the same thing at the source, but this will be connected to ground. Here, the number 3 here should be output, while this should be connected to ground to neutralize if there is an excessive voltage or current or noise from this place. That is what it means here. The same thing applicable to this place. This and this are the main terminal. 5 and 6 are the main terminal. Now we are to discuss about the inputs output specification of autocoupler. Autocoupler are often specified by their input and output circuit configurations. For example, input space consists of information about the light sensors, just what I explained here. Let me take you back. This input here, number 1 and number 2, that is where the information about the light comes from. Number 1, we collect the voltage from the source. After this diode might have finished its own job, it will direct it or send it straight to this detector or light sensors. Once the light sensors might have finished its own job, it will convert it to electrical signal. It means 1 and 2 is the input, while 5, 6, and 4 are the output. But remember, in types of trace, 5 and 3 are not connected. It's only 4 and 6, they are the main terminal. So the input space consists of information about the light sensors, which what I just explained, such as LED, forward current, power dissipation, or the wavelength. Output space often includes similar information about the device detector. One specification common to both circuits is isolation voltage. That is the most important thing so far. That is the job, the main work of autocoupler is to isolate voltage from the source to the other part of circuit. That is the main, is to separate it. Now, isolation voltage is sometimes referred to as input to output isolation voltage and is one of the more important autocoupler specification. Just as I said, this is the one of the more important autocoupler specification, which it carries the input current being the light emitting diode. It will transfer it to the light sensors or detector. After it might have finished its own job, it will convert it to electrical signal, and the electrical signal, it will give it to the necessary output that is needed. That is the work. That is the main work of it, is to what? To isolate the input and output voltage. Now in this case, isolation voltage represents the maximum the maximum voltage that can be applied to both input and output circuit while still remaining electrical isolation. The explanation of this place is, what I'm trying to say here is, the isolation voltage represents the maximum voltage that can be applied both the input as well as the output. If it is in terms of the autocoupler will take 20 volts, it means that the highest voltage or current that the autocoupler will collect is 20. Either it collects from the source 20 volts, after it might have finished its own job, it will send it to light sensors or light detectors. Once the light detector might have finished its own job, it will convert it to electrical signal and give it to other necessary output voltage that is required for it. So that is the most important thing of this isolation voltage. Now, in that case now, it's apparently that, which I have already explained all these things before, is obvious that I am using the trace as an example of this. Now, we have the finishing product here. Here, this is the duct, if you can see it, and it has MOC 3021, just as I explained. And that MOC 3021 is called the device number. It's called the device number. Why this F that you're seeing here is what? The company logo. The F that you're seeing there is the company logo. Why this 531Q, the Q stands for assembly package code. That Q it stands for assembly package code. I have explained this in the other of my previous video before. So I repeat it in case if you have not seen it. That is where I explain all these things. It also has every other, it could be K, it could be any number at all. But this K, it signifies assembly package code. So in that case, it's obviously that the description of this is written here. Anode, cathode, no connection, main terminal, no connection, main terminal. 4 and 6 are main terminal, while 3 and 5 are no connection. Anode is the one that collects the voltage from the source, while this number 2 pin, it will be connected to ground to neutralize if there is a noise or an excessive voltage from the source. It will neutralize it. After the diode might have finished its own job, it will send it straight to this light detector or light sensors. The light sensors will now have, it has a detector that will notice that there is a current coming. Once it has picked it, finished its own job, it will convert it to electrical signal. After that, this 5 and 6, this 6 and 4, which is the main terminal, will distribute it according to how it had been connected. Thank you for watching my video once again. Please, if you find my video useful, subscribe to my channel. See you in the next video.